TypeScript generics are one of the most powerful features in TypeScript. Nevertheless, most people skip learning generics because at first glance they look quite complicated. I mean, just look at this code. There are T's, K's, and all sorts of weird symbols. But don't worry, they are actually way simpler than you think. I mean, think about the following. One of the golden rules in programming is dry. Don't repeat yourself. Yet we constantly write the same functions over and over, just with different types. Let me show you what I mean. So right here I have an video.ts file. So a TypeScript file, nothing groundbreaking, who would have thought. And now inside of this file, I want to create a function. This function will take a param and then just console log it and return it. So let's just do a function. Let's call it, for example, getString. We can invoke it, we can get our string, which is of type string, and then we can open it. We can do our console.log. I will console log my string, and then I will return my string. And then I can also pass in return type, and I want to say, hey, I want to explicitly only return a string. Okay, nothing groundbreaking. This isn't a generic, this is nothing. This is just a function with types appended. But now let's say we want to also do the same thing for a number. Currently we only accept a string. This means if I call getString and try to provide an 5 as an argument, we get an error. Okay, then let's create another function. Let's call it getNumber. Let's get a parameter of type number. We want to return a number. Let's console log our number and let's return it. Okay, nice. Now I can call getNumber, I can pass my number, and now we are finished. But you see what we have right here? We have two functions which do at the end of the day the exact same thing. We could also do another example with a boolean. I can again call it, and then we will do the same thing with a boolean. Now we have three functions which at the end of the day do the same thing. They console log the value and they return the value. But let's again go to the start. We had this dry principle. Don't repeat yourself. So how about we don't repeat ourselves? How can we do that? Well, let's create one function. Let's call it getItem. Then let's invoke it and we will get an item. Now we could say this is of type any, but this isn't good TypeScript code. So let's say item could be of string, then it could be also of type number, or it could also be of type boolean. And then for our return type, we could say, hey, yeah, this could also be of type string, or this could be of type number, or this could be of type boolean. And you know what? At the end of the day, this code works. It's fine. This isn't a generic, but this code works. Instead of now having three functions, we have one function which does the same thing, right? But now let's say I want to add another type. I want to now also get, for example, an array string. So let's get the OR symbol. I want to get a string. Let me append my array. And now I leave this code. Oh no, I just made an error. I have to also return it, right? For the return type, I would also have to add my OR sign and then my string and append my array symbol. So as you see, this code is quite, let's say, problematic. It's very easy to make a lot of errors, which can have quite bad results. And as you also see, it's quite annoying to write this code, let's be quite honest with each other. So is there any fix which can create one function which allows multiple types without writing this annoying code? Well, there is. Generics. Yes! What are generics? Well, let's look at this code. This is a generic. We have this T, we have another T, we have another T. Damn, I have no clue what that is. Let's first of all cover what a generic is. So a generic is a way which allows you to create reusable components that can work with multiple, or in other words, with different types. With numbers, so with type number, with type boolean, with type string array, with type string in general, so with different data types. And at the same time, this generic also maintains its type safety. Item is of type T. At the end of the day, generics allow you to define a placeholder type. This is this T, and this can be specified when the function is used. Okay, let's maybe look at the code in more detail. Maybe you still don't understand it, and that's fine. So right here we have our function, getItemGeneric. Then we have these angled brackets, this T. Then as an param, we get an item, which is of type T. And then as a return type, we again have T. This T is first of all a generic type parameter. That's how you call it. And you can think of it like a placeholder for your actual type. And of course, you don't have to name it T. You can also name it A or B or C or XYZ. Honestly, I don't care. T in most cases makes the most sense, but you can use whatever you want. And now here's the thing. Once your function will be called, you will replace this T with your actual type, with your string, with your number, with your boolean, whatever. So let me show it to you. Let's call getItemGeneric, and then as an argument, let's pass hello. Okay, what did we just do? Well, if you hover over getItemGeneric, you will see these angle brackets, hello. Then for our item, we have a type of hello, and as a return type, we also have hello. What is hello? Hello is in string. This means our placeholder T is now in string. Our item type is a string and our return type is a string. Now, of course, you could also specify it. So we could use these angled brackets and then we could say, hey, this is specifically a string. So if you now hover over getItemGeneric, you now see our function. We see for our generic type parameter, we pass in string. For our item, we pass in string, and our return type parameter is also in string. And this T has a relationship, right? We pass in string as in type for the T. For the item, we also pass T. This means our item has to be of type T. And for the return type, we also pass T. What again was T? T was in string. Let's do the same thing with a number. So as in type, I want to now pass a number. Now I get an error because string is not of type number. So let's pass in 5. And now we don't get any error anymore. So let me again summarize it. So this T is your placeholder. It isn't a type. T isn't a type. A number is a type. A string is a type. T is only in character, in letter. Right here you add your actual type, in this case a number. And then your item and your return parameter have the relationship to this T. This T is a number. This means your item has to be a number and your return type parameter has to also be a number. So that's why I can't add in string right here, because it will see, okay, T is of type number, but for the item, we just passed in string. TypeScript will look at this and say, hey, are you stupid? You should pass a number, not a string. And as you also see, if I delete the number, TypeScript will automatically infer this as a string. So I don't have to add these angled brackets with my string. This is optional, but in my opinion, it's a good practice to explicitly say, hey, this is of type string or of type number, boolean, whatever. Great, so now we have a function which at the end of the day takes multiple types. It runs the same code and it's type safe, because again, if I hover over our function, you see I get returned in string and here I get returned a boolean. So we have type safety and that's great. But what is if we want to limit the amount of arguments, of types? Currently, we allow every type. The user could add in string and boolean and string array and whatever. I don't really care right now. But sometimes you want to limit the amount or the types which the user can pass. Well, if this is the case, then we can now add a constraint to our generic type parameter. Let me show it to you. Let's again copy this function. Then I will rename it to getItemGenericConstraint. And right now the code is the same, right? Nothing has changed. Only the name has changed. But now I want to say, hey, this T, our placeholder, can only be of type string and number. How do we do that in a generic? Or how do we say that? Well, we can use the extends keyword. So T extends, and we want to say, hey, it extends string or a number. So now we have a constraint. T can only be a string or a number, not in boolean, not in string array, nothing else. Only string or number. This means we can test it out. Let's call our getItemGenericConstraint function and let me pass true. We have an error. What's the problem? Let's hover over it. Argument of type boolean is not assignable to type string or number. If I pass a number, everything works again. And of course, I can also extend it to accept a boolean. If I now again add true, then everything will work again. Of course, again, I can explicitly also pass my type right here. So if I now pass an array string, so let's add a string, let's append the array symbol, we automatically get an error. String array does not satisfy the constraint string or number or boolean. So we have now type safe safety, we still have in generic, but now we can explicitly say what types we allow. Or in other words, what types we don't allow. And of course, you could also extend it by an object. So instead of right here expecting a string, number, or boolean, we could expect an object with a name of type string. And then if I call getItem generic constraint, I can only pass an object with a name and a string right here. If I pass a number, for example, we will again get an error. Alright everyone, so let's be honest. I think you now understand what a generic is and how it works. At the end of the day, you can create one function, reuse it with multiple types, or you can accept multiple types. You can also use the extends keyword to constrain your types. You can say, hey, I only accept in string or number or boolean. I don't accept in string array or something like that. So this is what a generic is. But now I want to look at a bit more of, let's say, real-world examples. These are also real-world examples, but let's look at something more specific. So let's imagine I want to create two APIs. One API will be there to return user data, and the other API will be there to return data of to-dos, because you have some sort of to-do management application, you have users, to-dos, and now you want to return both for your dashboard, for example. So let's create the example. What do? Well, you first of all probably create an interface for the user. Then what data does the user have? Maybe an ID of type string and maybe a name also of type string. Okay, then let's also create an interface for our to-do. What data does our to-do have? Maybe an ID also of type string, maybe a title of type string, and maybe a completed boolean. So to know if the to-do is completed or not. So now we have our two interfaces, and now let's fetch our data. So let's do an async function. This will be called get users, and inside of here I want to now fetch some data from JSON placeholder. I await my data and I return my data. Okay, nice. So now we have our function, and now let's do the same thing for our to-do. So let's copy it, let's paste it, let's rename it to, for example, get to-do, and let's also update our URL. Okay, so now we have our two functions, but if I hover over data, data is of type any. How can I fix it? Well, let's again copy paste our async function get users. Let's call it get users typed. How do I pass a type right here? Well, we can pass in return type. What is the return type? Well, it's in promise. Let's use our angled brackets, and then this URL at the end of the day returns an array. So let's pass our user interface and let's append our array symbol. So now within promise, we pass our generic symbols. That's how I call them. And then we pass our user, which is an array. If I hover over data, data is still of type any, but if I await my data, so constant data equals to await get users typed, and if I hover over data, you now see data is of type user array. So this in theory works as you see. But what is again if we can create one function instead of creating two? Again, the dry principle. Don't repeat yourself. Because in this case, I would have to now create two functions. One will be get users typed and one will be get to-dos typed. But I want to create one function. So let's create an async function. I will call it get items. Then we can invoke it and open it. As in param, I will want to get an URL, and this will be of type string. So the URL will be this JSON placeholder API. For the get to-dos example, this will be /todos, and for the users, this will be /users. Then inside of here, we want to create a constant response. As an argument for our fetch call, we will pass our URL, then let's await our data, and now this is finished. But here comes the problem. If I now at the end of the day await get items, so if I do in constant data equals to await get items, and if I pass in URL as an argument, and if I hover over data, data is of type any. Again, this is not what we want. We want to get type safety. So let's convert this function to a generic function. How do we do that? Well, first of all, we have to pass our generic type parameter. We do that before our parentheses. So here we can get our angled brackets, and we want to get our t. Again, t makes the most sense, but we can also call it a in this example. Now a at the end of the day, as you all know, is our placeholder. Later on, we will then convert it to our actual type. And now we want to use this a. Let's actually call it t. A confuses me a bit. And now we want to use this t for our return type. So for our return type, we can again create our colon. This will be in promise. Then let's pass our angled brackets, and inside of here we want to pass our t as an array. So now our getItems function is type safe. T is again our placeholder, and then later on when we pass in type for t, it will automatically create a relationship to this t, because t at the end of the day is equal to t, if this makes sense. Whatever I pass here is what this t will be. So now we can await our data, so we can do in constant data equals to await getItems, and then as an argument I can pass my URL. But now we have one problem. If I hover over data, data is of type unknown. Now it's not of type any anymore, but it's of type unknown. That's because t, this placeholder, hasn't really been swapped out, if this makes sense. We haven't passed in type. So let's change that. Right here, before our parentheses, we can get our angled brackets. We can pass our user type, which is of type array. This means if I now hover over data, data is of type user array. But now I made a small mistake. If I hover over data, data is of type user array. This does not make any sense. Why is that? Well, that's because we passed for our return type that t is of type array. This means we don't really have to pass this array inside of here anymore. If I now hover over data, data is of type user array. And of course, we can also create the same example for our to-dos. I can copy paste it. We can rename it to to-dos data. And then for our type argument, we of course don't want to pass our user anymore, but instead our to-do. And again, we don't have to append the array symbol, because we already do that in our return type parameter. If I now hover over my to-dos data, you see it's of type to-do array. Okay, this example is now finished. This is one real-world example. Let's look at another real-world example. So now I want to create a function which accepts multiple type parameters. So currently we only accept one. If I pass for t string, then this return type parameter has to also be t. It can't be k, or it can't be number or anything like that. It has to be t, because we have this relationship. But now I want to accept two type parameters. So let me show it to you. This at the end of the day is a function pair. We again have our type parameter. This is k and v. This could also be a and b, or c or d. Then we accept two parameters, key and value. Key will have a type of k, and value will have a type of v. And then we have our return type parameter, and this is an array of k and v inside of there. This is a tuple, if you didn't know. And then inside of our function, at the end of the day, we again return our key and value, as we show it in our return type parameter. So now we can call our function. We could create a constant pair 1, and this will be equal to pair. And then as an argument, we can provide hello and 100. So k would now be of type string, and v would be of type number. And if you now hover over pair, you will see for our generic type parameter, we now again pass string and number. Keys of string, values of number. And for our return statement, we have a tuple of string and number. And of course, I can also explicitly again mention it here. We can pass our type argument, and this will be of type string and number. And if I pass for the second argument also a string, we instantly get an error. And if I hover over the error, it says, hey, argument of type string is not assignable to type number. And of course, you could also constrain your types. So for k, we could add our extends keyword, and we will only allow in string, for example. Let me delete the generic type argument, and instead of now passing hello, let me just pass 555. You'll see we will automatically get an error, and if you now hover over the error, it says argument of type number is not assignable to type string. So now we also constrained our types. K can only be a string, but v can be whatever it wants to be, a number, a boolean, I don't care. So this is another real-world example with multiple types. Okay, so now we have created a function which takes two different types, and then at the end of the day returns a tuple with these two types, k and v. So now we have looked at quite TypeScript specific examples, but let's look at a JSX example, at a React example. So right here I've created a little website where a user can create a new user. Yeah, I mean, makes a lot of sense, but who cares? So I can provide a name of Jan and then an age of, for example, 100. Then I can click on on create user, and then we have a current user with a name and an age. And I implemented this with the use state hook. So we first of all have state for our user object in general. So in this state, we will store this user with the name and age. And then I also have two states, first of all for the name, and then also a state for my age. So if you go to the UI, we at the end of the day have a form, and then we have an input and we have an onChange handler where I update my user name, so the state, and also in this input, I update my user age. And of course, we then have our function create user. We check that the user has provided values, and then we set our user with an object, and then we pass our name and age. But as you see, we have a few errors. So for name, I have an error. Then right here for name, I have an error. And just in general, this code does not have any TypeScript right now. So if I hover over user, so in my use state hook, if I hover over user, it says user is of type null. I mean, yeah, I guess this makes sense. As an initial state, I pass null. And React is kinda stupid, or TypeScript is kinda stupid right now. It thinks, okay, so the user passes null as an initial state. This means user will always be null, right? No, it won't be null. The initial state is null, but once my create user function runs, I want to update this state, and instead of passing null, I will pass an object with the name and age. This means inside of here, I want to say, hey, this state hook could either be null or it could be of type user. Because if I currently hover over use state, you will see as a generic type argument, we pass null. And then our initial state is of type null. And then our set state action, so set user, is of type null. But instead of passing null for our generic type parameter or argument, you can call it whatever you want to call it, instead of passing null, we want to pass null or user. So let's first of all create our interface, which will be of user. And then inside of here, we get a name and we get an age. Name is of type string, age is of type number. And then for our use state hook, I want to now pass my generic type argument. So before our parentheses, we can get our angled brackets, and then this could be either of type null or this could be of type user. Again, you do that with this vertical line. If I now hover over use state, it says, hey, use state could either be of type user or null. So this is our generic type argument. And then for the initial state, this is user, this is either of type user or null. And our set state action, this is the set user, could also be either of type user or null. Let's also do the same for our username and user age. We don't have to do it inside of here because React infers this as a string. So if you hover over use state, it says, hey, we can only accept a string. And the same thing is true for our age. If I hover over use state, we have our generic type argument, which is number, which means user age can only be a number. Nevertheless, as you know, I think it's in good practice to explicitly mention it right here. So this will be of type string. And then let's do the same thing for our number and or for our age. And this will be also of type number. And if you again go back, you will see the code still works. I can provide my values. Now I'm only 5 years old. And if I create my user, everything works. And we don't have any errors inside of here. And that's nice. Okay, friends, so I think we're now kind of finished. So as you now see, generics are actually kind of simple and relatively easy to implement. They are very powerful because they give you type safety and allow you at the same time to accept multiple, or in other words, different types. Now, I will be honest with you, generics can become very complicated if you overdo it. But let's be honest, I don't think your project needs very complex generics. In most cases, you need simple generics as we just covered them in this video. So yeah, I think that's all I wanted to say. I hope you enjoyed this video. Don't forget to like and subscribe. It would mean a lot to me. So yeah, please do it. And it would also mean a lot to my heart. Please enjoy your day. I hope I can see you in the next video. And now, over and out. Bye bye. Whew. By the way, friends, sorry, the background has changed, but yeah, I guess that's fine. You will survive it. We now know what generics are. That's the important part. Okay, bye-bye, bye-bye, bye-bye.